My name's Pete Simic. I'm a Master's of Science in Ecology student here at Western, and I'm also a research technician with the Fort Collins Science Center. And today I'll be talking a little bit about my thesis project titled Using the Past and Present to Understand Fire Ecology in Sagebrush Habitats of the Gunnison Sage-Grouse. If it comes up there. There we go. First, I'd like to acknowledge some collaborators and funding support. Dr. Ellis Margolis, Dr. Jonathan Coop, Brian Stevens, and Manny Lopez. And funding support from USGS, EMA Wildland Fire Program, and the BLM Gunnison Field Office. So the main question we wanted to ask in this project is, what was the historical role of fire in sagebrush landscapes within the Gunnison Sage-Grouse range? So changing fire regimes is a great concern within Gunnison sage-grouse habitats. And we would expect that fire regimes and landscapes were altered by Euro-Americans over the last century and a half. And so in the context of climate change, changing fire regimes, changing land use, what can we learn from the past to use for contemporary management? So we had a couple objectives in answering this question. The first objective was we wanted to reconstruct the fire history over multiple centuries of the Upper Gunnison Basin using tree ring fire scars at sagebrush forest ecotones. The second, we wanted to determine the effects of recent fires on vegetation within Gunnison sage-grouse habitat. And then we wanted to bring the findings of these two objectives together to gain insight into how Gunnison sage-grouse habitat has changed over time. So we sampled fire-scarred trees at sagebrush forest ecotones across the Upper Gunnison Basin. We collected 177 tree ring samples from 10 sites across the Upper Gunnison Basin, and you can see this map here in the bottom left. Those 10 sites were either within currently occupied habitat or in historic habitat directly adjacent to occupied habitat. We then dated the year and seasonality of those fires using dendrochronological methods. And this picture on the right came from one of our fire history sites, Yellow Pine Ridge. And it's just a great example of that sagebrush forest ecotone. So tree ring fire scars can record the year and oftentimes the season of historical fires. So on the left is a stump with a couple fire scars from one of our sites. And on the right is a cross-section, a sample from Old Monarch Pass, one of our fire history sites. This came from a living ponderosa pine tree. So basically, essentially, we're using those annual tree ring growths and patterns within that annual tree ring growth to date when the fires happened. This particular sample was scarred by fire twice, once in 1798, once in 1842. Additionally, we can date the seasonality of those fires based on the position of that fire scar within the tree ring. So we found that there was a history of repeated moderate frequency fire in the Upper Gunnison Basin. Site level mean fire return intervals was 41.3 years across the 10 sites. So this is the mean of the mean. So the 10 fire history sites each had a mean fire return interval, an average number of years that fire returned. So on average from those 10 sites, it was 41.3 years. Mean fire intervals varied from site to site, ranging from 18.2 years to 84 years. So there's a few things I want to point out about this chart. This is a composite fire history chart of the Upper Gunnison Basin. On the bottom, we have our timeline, so 1350 to present day. The black horizontal lines represent each fire history site recording. The black vertical tick marks represent fire events. And then that horizontal red line at the bottom represents synchronous fires, or fires that occurred in 2 or more sites. And these vertical orange drop lines represent the same thing. So there was a history of repeated fire in the Upper Gunnison Basin for over 500 years. The site level mean fire return interval for fire burning synchronously between 2 or more sites was 23.6 years. So on average, every 23.6 years, a fire occurred in at least 2 fire history sites. And then we saw an abrupt cessation of repeated fire circa 1900, followed by over a century that was essentially fire-free, which caused some sites to miss up to 8 fires. So there's a couple things I wanted to mention here. So why do we care about synchronous fires? So why do we care about fires that occurred in at least 2 fire history sites? Well, this fire history data came from sagebrush forest ecotones, from tree ring fire scars at those ecotones. And what we were interested in is the fire history of that adjacent sagebrush. So if you have 2 fire history sites with sagebrush in between those 2 fire history sites, and they recorded fire in the same year or the same seasonality, that's consistent with that adjacent sagebrush burning in that same year. Additionally, a lot of these synchronous fires were not associated with drought years. So if they were associated with drought years, that'd be more consistent with individual fire events happening all across the Upper Gunnison Basin. So that's consistent with widespread fire in the Upper Gunnison Basin. Years like 1872, we saw 4 fire history sites burn, all separated by currently occupied Gunnison sage-grouse habitat. Another thing I wanted to mention is that in the 1700s and the 1800s, we see the highest frequency of fire and synchronous fires. So this was a time in the Upper Gunnison Basin where the range of the Gunnison sage-grouse was much larger than it is today, and population numbers were presumably high and stable. Another thing I wanted to mention is that that shift in fire regime circa 1900 correlated with the beginning of the decline of the Gunnison sage-grouse, in addition to livestock grazing, development, mining, and things of that such. Okay, so we were able to date 85% of our fire scars. The majority of fire scars occurred in the early season, the spring and the early summer. So you can see 53% of our fire scars occurred in the dormant woods, so before the tree started growing, so early in the season. And that trend slowly tapered off where we have very few late season fires. Early season fires consistent with wind spreading fire to adjacent sagebrush. In the spring and the early summer, we have some really strong winds here in the Upper Gunnison Basin, as you noticed today if you got outside. And then early season fire is also consistent with human ignition sources because this is prior to the lightning season. And in addition, those fire events occurring outside of those drought years is also consistent with human ignition sources. Okay, on to our modern fire effects. We conducted vegetation surveys, 50 in recently burned areas, 50 in unburned areas. Those 50 recently burned areas came from 12 different fires from 8 distinct years, ranging from 2001 to 2021. We used BLM AIM protocols to assess vegetation structure and composition, which included line point intercept, continuous line intercept, and species richness. We then compared woody, graminoid, non-native forbs, sagebrush, and grass cover between burned and unburned sites. Okay, so comparing woody and herbaceous cover between the burned sites and the unburned sites. So if you look at figure A up there, we have woody plant cover being compared from the burned sites to the unburned sites. And there's a significantly higher amount of woody plant cover in the unburned sites. And after fire, woody plant cover gradually increases, slowly returning to its pre-fire state. If you look at figure C, we see the opposite trend, significantly higher amount of herbaceous plant cover in the burned sites compared to the unburned sites. And we did not see a significant change in herbaceous plant cover with time since fire. However, that was nearly significant. The p-value was 0.05. So perhaps with some older fires, we would have seen a significant trend there. I did want to mention that this herbaceous cover largely consists of native perennial grasses. I'll get into non-natives here in a minute, but I thought that was worth mentioning. And another thing I wanted to mention is the woody plant, the average woody plant cover 20 years after the fire is almost identical to the average woody plant cover in the unburned sites. However, the average herbaceous plant cover 20 years after the fire is still much higher than the average herbaceous cover in the unburned sites. So that suggests that fire had some lasting effect on herbaceous plant cover and even some type of invigorating effect on herbaceous plant cover where it increased even 20 years after the fire. It also suggests that sagebrush landscapes take at least 20 years, more than 20 years to recover after a fire. And I wanted to show some figures comparing total foliar cover and bare ground in the burned and unburned sites. We did not see a significant difference in total foliar cover or bare ground between the burned and the unburned sites. So that increase in herbaceous plant cover is not coming at the expense of total plant cover, which is important. We saw no significant relationship with bare ground and time since fire. However, total plant cover increased with time since fire. Okay, on to woody height and herbaceous height. So if you look at figure A, average woody height was significantly greater in the unburned sites compared to the burned sites. Conversely, figure C, herbaceous height was greater in the burned sites compared to the unburned sites. With average woody height, we saw a significant increase with time since fire. However, we did not see a significant change in herbaceous height with time since fire. And another thing I wanted to point out here is that the average woody height 20 years after the fire is actually still significantly lower than the average woody height in the unburned sites. So it had not yet reached that level of woody height that was there pre-fire. However, the average herbaceous height 20 years after the fire is still much greater than the average herbaceous height in the unburned sites. So again, fire has some type of lasting effect, invigorating effect on herbaceous plant height where it's greater than it was before the fire occurred. So this is a picture of the Rainbow Lake fire that burned in 2016. This picture was taken in 2021, 5 years after the fire. So as you could probably guess, on the right side is the unburned section, and on the left side is the burned section. And a couple things to notice, the patchiness of the sagebrush in the burned section, the abundance of rubber rabbit brush that's coming back there in the burned section as well. And also just the abundance of those native grasses in that burned section compared to the unburned section. You see that unburned section between those shrubs, you could see there's a good amount of bare ground, where in the burned section, you don't see much bare ground. You see a good amount of herbaceous plant cover. Also, anecdotally, while we were sampling here, we did see multiple Gunnison sage-grouse using this burned site. So that's a piece of anecdotal evidence there. Okay, so there's this big question here, annual non-natives. Does fire increase annual non-natives in the Upper Gunnison Basin? So we did see a significantly higher amount of non-native plant cover in the burned sites compared to the unburned sites. However, the cover was still low in both burned sites and unburned sites. It was 2.6% in the burned sites compared to 0.8% in the unburned sites. Additionally, we saw a significantly higher amount of native plant cover in the burned sites compared to the unburned sites as well. And there was no trend with native or non-native plant cover with time since fire. So cheatgrass, this is the big species in question here. We did not see a significant difference in cheatgrass between burned sites and unburned sites. In fact, we saw very little cheatgrass cover across our 100 sites. Cheatgrass was present at 3 out of our 100 sites, and 2 of those sites were actually unburned sites. Out of our 109 species found on our plots, only 5 were non-native species. Those were cheatgrass, crested wheatgrass, narrowleaf plantain, common dandelion, and yellow salsify. And out of those 5 species, only crested wheatgrass was greater in the burned sites. And it's worth mentioning that crested wheatgrass was seeded here historically to improve rangeland. And in a lot of places, it's considered more of a naturalized perennial grass, or at least a more mild, noxious annual grass compared to cheatgrass. Another thing I wanted to mention is though cheatgrass is not a problem right now in the Upper Gunnison Basin, this could very likely change in the future with future climate change and future drought. So cheatgrass still needs to be heavily monitored and treated in the Upper Gunnison Basin. Another thing I wanted to mention is I just wanted to highlight the difference in sagebrush landscapes across the western United States. Between the Great Basin, Wyoming, and the Upper Gunnison Basin, the effects of fire are much different across these different sagebrush landscapes. Okay, so to sum up our findings, we had frequent synchronous fires outside of drought years, which is consistent with adjacent sagebrush burning, fires occurring in the spring when winds are high, spreading fires to adjacent sagebrush, burns exhibiting reduced sagebrush cover and increases in graminoids relative to unburned sites, and these shifts diminished over time but persisted for at least 2 decades after the fire. So let's tie this all together. So in at least some portion of the Upper Gunnison Basin, the historical condition was likely characterized by a patchy mosaic of recent burns. And changes in historical condition need to be considered when using the past to manage the present. We can no longer say, hey, this was the fire regime historically, let's just replicate that today to recreate those historical conditions, because a lot of those historical conditions have changed with climate, with drought, which may affect forb and herbaceous plant desiccation, the ability for sagebrush to recover, annual exotic grass invasion. We heard a little bit about ravens and coyotes yesterday. Also, there's been changes in land use with livestock grazing and development and the such. So co-production between land managers and researchers, I think, is really important. When in this conversation with fire and sagebrush and Gunnison sage-grouse, I think these historical conditions and how they've changed really need to be considered, and a lot of research needs to be done when making these land management decisions. So now I have a question for all you Gunnison sage-grouse experts out there. So the Gunnison sage-grouse habitat requirements vary seasonally, right? From barren landscapes for leks to forbs and grasses in the summer for a summer food source, to dense sagebrush for nesting and wintering. So to what extent did this patchy mosaic of recent burns help meet all these different habitat requirements of the Gunnison sage-grouse historically? And how can we use this past? How can we use this information to manage, to make contemporary land management decisions? I think it's really important to consider the spatial and temporal complexity of Gunnison sage-grouse habitat requirements when managing their habitat. I'd like to open it up for questions.
I thought it was really interesting that the historic burns were spring burns, because it seems like it's really hard to get things to burn in the spring when doing prescribed fire. So was that ignited by Native Americans, or are there any thoughts about why that was the way it was?
So it's consistent with indigenous burning. However, there's no good way to understand that. You know, before livestock were introduced to the Upper Gunnison Basin, there was an abundance of those grasses in the spring. So there might have just been a natural fire regime that benefited from those fine fuels, and when those fine fuels were altered, that altered the fire regime. So a higher abundance of spring fires is consistent with indigenous burning, but there's no real good way to understand that definitively.